Hi guys, I just recorded for 17 minutes because I'm learning how to do this with no audio. How unuseful is that for you guys? But we're going to try this again. We're going to finish up the lesson with some examples, and I hope it is helpful. We're right now where we're talking about postulates. We just talked about our undefined terms, our defined terms, the basic things that build geometry, points, lines, planes, and space. We talked about collinear, how to use the correct notation. But now we're going to talk about the fundamental elements, the postulates. A postulate, what is it? Or an axiom, an element, is an accepted statement of fact. It's not provable. Now, the example I gave earlier, and I kind of want to emphasize, is the Christian faith. We used God is real. My friends, you cannot prove to an atheist or a Buddhist that God is real because that's not the fundamental basis of their belief. An atheist, for instance, their basic postulate of their belief is the fact that God is not real. So for us, the fact that God is real is the basis of all our faith. Otherwise, what we do here at Wayne Academy is meaningless. But I know God's real, and if I have Him as your Savior, you know He is too. But for most people, that's not their postulate, their basic belief. For me, it is. And so in geometry, you know, trying to do a comparison here, we have a basic belief. And Euclid was really good at setting this up. For instance, on this one, the very first one is the following. Through any 2 points, and I am going to abbreviate points here, there is exactly one line. Now, this is again kind of common sense. Another way of saying this is any 2 points determine a line. How many of you have ever heard the saying, the shortest distance between 2 points is a straight line? Well, that's geometry based, because notice, when I draw a point, and I'm going to call them A and B, I can draw one line through there. Now, if I could draw that line more than once through those points, we have some issues. That means the line's no longer straight. And in geometry, Euclidean geometry, we define that a line is straight. So it goes on forever. So you only can get one. Now, think about why we name any line by 2 points, because those 2 points determine that line. There can be more points on there, fine, but we have those 2 points. All right, our next one also is a very common sense thing, and one of you are like, yeah, Gregerson, this makes sense, is the following. If 2 lines intersect, then, and by the way, intersect is like an intersection of 2 roads, then they intersect in exactly 1 point. I'll spell it out this time. Poorly, but I'll spell it out. Think how common sense is. Here I have a straight line. Here I have a straight line. They intersect right here, which is at a location, like I'm going to call it point A here in this case. If they did it again, I mean, if they intersected twice, no longer would they be lines, they'd be curves. And that's not physically possible in geometry when I talk about a line. A curve is a curve, but here, that's not a line. Now, in some college geometries, some geometries I've studied, that's actually are called lines, but not in geometry world. Ours are always going to be straight, and they go on forever. So that's our second postulate. Our third postulate is kind of cool. This talks about 2 flat surfaces called planes. If 2 planes intersect, all right, then they will intersect in exactly 1 line. Now, This is kind of easy. Think of two walls and where they intersect. They intersect and how much you go, the corner. What shape is the corner? The corner is an up and down line. Let me give you some examples that will give you some visual aids. You can draw like a box, and you have this plane right here, and this one going right here. Where did they hit each other? At this corner. There's that line. And they go on forever. So that's cool. Another way that you'll see very commonly drawn is you're going to get two planes, one going this way, and we'll dash this one through a little bit. And here's your other line. So it's like one's going up and down. Here's A, here's B. Those are two intersecting lines. Now this always happens. So when you hear, they go, what's the intersection of two planes? If you don't write a line down, you're wrong, because the postulate says you have to get a line when two planes touch or when two planes intersect. All right, our last postulate is all about the planes, and it's actually probably the most useful postulate that we have. Through any three non-collinear points, there is exactly one plane. Basically, this is the triangle idea we use to name planes. If I have any three non-collinear points, I can make that triangle. Well, they lie in a plane. So think about how this would help us. An example would be a tripod. Tripods are used because, especially by like surveyors or photographers or videographers, because they can put the three legs on uneven ground, but they'll still be balancing on a flat surface called a plane, because any 3 points give us a flat surface. This is why your mother always says, don't lean back in your chair, because if you lean back in your chair, you're only balancing on 2 points, which is a line, right? Because any 2 points would give you a line. Make sure I draw an arrow there. And so you're going to more likely fall. You're like balancing on a high wire. But if you put all 4 legs of the chair down, you're balancing now on a plane. You're stable. You're safe. You're not going to fall over. So think about that the next time you're balancing. I don't think your mom's going to care if you're balancing on a line or a plane. She just doesn't want her chairs ruined. But that's actually the geometric reason why. Kind of cool. One thing I want you to remember is we don't memorize the numbers. We memorize the words. Geometry is all about memorizing the topics so we can apply it. But let's do a couple examples on this back page. For instance, first one, number 1, name AB in another way. Well, here's line AB. Connect the points. La, 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 la. Connect the points. Now, I sang that to you guys in class, so please don't go playing this to your parents. All right, so we have a line, BA. You could flip it around. You could also do line AC. Or you can line BC. All of those are exactly the same line. So you can choose any of them. All right, let's find another one. Let's do part 2. It says, give 2 other names for plane Q. Okay, 2 other names for plane Q. So here's plane Q. I just need 3 non-collinear points. So I'm going to go plane AED. Or you can go plane again. How about BCD? For some reason, I'm liking that one now. I cannot use F. F is on the line that's going through the plane. It's just kind of like stabbing it, so don't do that. Okay, I like talking about number 3 here because that's kind of a critical one for us to understand. It says Y, and this should say plane, by the way. EBD is not an acceptable name for plane EQ. Now, here's EBD, right here, this line. It's on the plane. It's 3 points. Why doesn't it work? Well, the reason why is because of it being linear. More than one plane can intersect it. Like I can literally have a flat plane coming down and hit this, because any 2 planes that intersect intersect, I want to say it this way, in a line. That line then is in two different planes. How do I know which one works? So always, always go 3 non-collinear, okay? All right, let's do some other good ones here. Also, don't forget that planes can be there and you don't see them. For instance, I like talking about number 18 here. It says, find the intersection of the following lines and planes in the figure, right? I have planes GHPN. Now, notice that's not drawn in, but I could easily draw in the plane. It's slicing through the middle, diagonally across that plane. I can crisscross. I can go one this way, one going from here down. It's like pulling a shade or roller down. And I want to know the intersection of GHPN and KJP, which, by the way, KJP includes N, is the bottom one. So I got this bottom one and this one coming in an angle. Where do they hit? Well, they hit right here at PN. So that's going to be at line PN. Now, there's a lot more examples I could do. I don't want to take tons and tons of time, but I want you to come in and ask questions if you have any. I hope this will give you a basis and help. I hope these are going to be helpful for you and your parents and your friends as you're working on